All right, so we're looking at doing some operations on functions here. As we can see, we have a function f, we have a g function. First thing we want to do is we want to add these two functions together. So what we're going to do here is we're going to take function f, we're going to take function g, we're going to add them together, and the x is still going to be x. So I've got my f function, x plus 3. I'm going to be adding that to my g function, 2x squared plus 4x minus 6. I would keep these in parentheses until we set up our operation. Now we can see we're adding one of these. So we can drop these parentheses and we can combine like terms. I don't have any like terms for my 2x squared. It's going to go in front here. We've got 4x and x. Well, that gives us 5x. And then we've got a 3 minus 6, which gives us a negative 3. So there is our f plus g of x. Moving down to our f minus g of x, well, of course, we're going to take our f function, we're going to subtract our g function here. Very similar to our setup for the last one, but as you can see, we're going to be subtracting this one. We got 2x squared. Now it's very important again that we've put these in parentheses because we're subtracting all of this one. We essentially distribute that subtraction sign in here, at least that's the way that I like to see it. Subtracting 2x squared, subtracting a positive 4x, which is now just subtracting 4x, and subtracting a negative 6 is now adding 6. Notice it changed the sign of each term inside of there because we were subtracting it. Now again, we combine like terms, no like terms once again for that x squared. X minus 4x is now a negative 3x, and we have 3 plus 6, which gives us 9. That was good. That is our f minus g of x right there. All right, moving on to this, which notice this is f times g. This is a closed circle. It's a dot right there, so it's not f composed of g. You'll see that somewhere else. But that is a dot, so we're multiplying those. So we have f, x plus 3, times our g function, 2x squared plus 4x minus 6. We're multiplying these two expressions, so essentially I'm going to be distributing my x. X times 2x squared is now 2x cubed. X times 4x is now 4x squared. X times a negative 6 is now negative 6x. I distribute the 3. 3 times 2x squared is 6x squared. 3 times 4x is 12x, and 3 times a negative 6 is a negative 18. Combine like terms. Oh, no like terms for my 2x cubed. For 4x squared, I also have a 6x squared, which gives me 10x squared. I've got a negative 6x and a positive 12x, which gives me a positive 6x. And then finally that minus 18 right there. I've cleaned it up. This is my f times g of x. Finally, I have f divided by g of x. And I'm going to set that up just as you would imagine. I've got my f function on top. I've got my g function on the bottom, 2x squared plus 4x minus 6. And in order to simplify this or try to clean this up at all, we're going to need to factor the top and the bottom completely and see if we can reduce. Well, the top is factored. There's no common terms. It's not a quadratic or anything higher, so we're good with that. On the bottom, though, I can pull out a 2. And that is a quadratic that can be factored right there. So I have that x plus 3 on the top. On the bottom, this factors to be x plus 3 times x minus 1. And this simplifies down completely, or just a little bit more, sorry. We've got our other color. X plus 3 is on the top and the bottom, which gives us a 1 on the top. That's not 0, but something divided by itself gives us 1. And on the bottom we have 2 times x minus 1 right there. You can leave it like that. That looks good. And so we simplify this down. This is our f divided by g of x. So really the only other thing you might, that might be asked in problems like this would be like, what is the domain of these? So for most of these, as you can see, the first 3 that we did, well, this one, that is a polynomial. The domain's all real numbers. So if you had to say something, you could say you could use the real number symbol, or you could say, hey, all real numbers. Right, those are the same thing. Here, it's a polynomial, all real numbers. Here, the domain is all real numbers because this is a polynomial. This is a little bit more interesting. So again, we're going to concentrate on this one because it's a little bit different than the rest. This is not a polynomial. There is a variable in the denominator. So in order to find the domain, well, you kind of need to think of what's not available in the domain. And when we factored the denominator here, there is 2 things we can see that would make this equal 0. If you were to use the zero product property, set this equal to 0, you would see that x cannot equal a negative 3 and x cannot equal a positive 1. So the domain is any real numbers besides these. So if you're thinking of real numbers, well, we're starting at negative infinity, and this goes to pretty much negative 3, but I'm going to put a parenthesis right there to say that's not included. And then we've got from negative 3 to 1, and then from 1 to positive infinity. It doesn't include the negative 3, so I put a parenthesis there. It doesn't include the 1, so I put a 1 near the parentheses, and we combine all of these with union. So really it should be nice one line, but I ran out of room there. From negative infinity to 3, small little microscopic gap. From negative 3 to 1, it doesn't include that one, but then it goes onward to positive infinity. That would be the domain for that one.